Alright, let's solve problem 24 on the 2008 AMC 10B. So quadrilateral ABCD has AB equals BC equals CD, angle ABC equals 70 degrees, and angle BCD equals 170 degrees. And we're asked to find the measure of angle BAD. Okay, so let's first draw out the quadrilateral. So let's draw, right, we have these sides equal to each other, like sort of like that maybe. Okay, and we'll label this point A, B, C, and D. So we know that all three of these sides are equal to each other. So let's start off by just drawing the diagonals, because then we'll get a bunch of isosceles triangles, right? Okay, now with a bit of angle chasing, right, we realize this is 65 degrees, this is 5 degrees, right, because this is going to be an isosceles triangle, and this is 120. So 50, or sorry, not 120, but 170. So this is going to be 55 degrees here. This is going to be 115 degrees. This here is going to be 5 degrees. And then what we essentially want here is, and then this is going to be 55 degrees, right? This is isosceles. And then this is obviously 60 degrees. This is 120. Okay. And then we want angle BAD. So let's call this angle here alpha. And then we'll call this angle here 60 minus alpha. Okay, now let's apply law of sines. So let's first look at triangle ABF, right? Or let's call this intersection point here E, right? So on triangle ABE, right, let's just do AB over sine of 60. Okay, AB over sine of 60, and then we'll have, so we can translate that to this triangle now. Since AB and CD are the same length, and they have the same angle, right, this is also 60 degrees here, right, AB over sine of 60 is the same thing as saying CD over sine of 60. That's the same thing as CE over sine of 5 degrees. CE over sine of 5 degrees. Okay, and now we can take it back to triangle ABE, right? So after we've done AB over sine 60, we can do AE over sine 65 degrees. Okay, so now what this implies here is that AE is going to be equal to AB sine 65 degrees times 2 root 3 over 3, right? Or 2 over root 3, but we just rationalize the denominator, because this is just finding the value of sine 60 degrees and plugging it in. And then we also have that CE, right? CE is going to be equal to AB sine of 5 degrees times 2 root 3 over 3. So AB sine of 5 degrees, oops, AB sine of 5 degrees times 2 root 3 over 3. Okay, so now if we add up AE and CE, then we'll get this side length here AC. And then once we have that side length AC, right, then what we can essentially say is that AB over sine of alpha is going to be equal to AC over sine of 65 minus alpha, right? So let's write that out now. So let's get rid of all of this first. Make some room. Okay. So now AE plus CE equals AC, right? So that means that AC is going to be equal to 2 root 3 over 3. And then we'll have sine of 65 degrees, or times AB, right? And then we'll have sine 65 degrees plus sine of 5 degrees. And then we'll divide this by sine of 65 minus alpha. Okay, and then by law of sines, that's just going to be equal to CD over alpha. But CD is the same length as AB, so we can just replace it with AB. So now let's get rid of all of this. So that's going to be equal to CD over sine of alpha, which is equal to AB over sine of alpha. Okay, now let's only focus on this expression and this expression. The AB's conveniently cancel out. So now we're left with the trig problem here, right? We have 2 root 3 over 3 times sine of 65 degrees plus sine of 5 degrees over sine of 65 minus alpha equals 1 over sine of alpha. Okay, so let's write that out now, right? So now let me get rid of all of this. Okay, so I took that equation and I cross-multiplied both of the fractions to come to this. So 2 root 3 over 3 sine A times sine of 65 plus sine of 5 is equal to sine of 65 minus alpha. Okay, so now what we essentially want to do is simplify sine of 65 plus sine of 5 degrees, right? So let's first look at the formula 2 sine A cosine B. right? We know that this is equal to sine of a plus b minus sine of a minus b. Or sine of a plus b plus sine of a minus b. So now if we do 35 and 30, right? Then we'll have, like, if we let a equal 35 and b equal 30, then we'll have 30 plus 35 and we'll have 30 minus 35. And I specifically chose 30 because we know the value of sine of 30, right? That just comes from a 30, 60, 90 right triangle, right? We'll always have x, x root 3, and 2x. So sine of 30 is obviously just going to be 1/2, right? You can just draw a simple right triangle, or if you have them memorized, you obviously know it's 1/2. So if we let a equal 30, let's say, or let's let a equal 35 and b equal 30, right? So then we'll have cosine of 30, which is sine of 60. That's going to be root 3 over 2. So yeah, cosine of 30 is going to be root 3 over 2. So now we have 2 sine 35 degrees times cosine of 30, which is root 3 over 2, is going to be equal to sine 65 plus sine of 5, right? So sine of 65 plus sine of 5, that just simplifies to root 3 times sine of 35 degrees, right? Root 3 sine of 35 degrees. So now let's plug that into here. So if we plug root 3 times sine of 35 degrees, the root 3's here will multiply, and that'll cancel with the 3. So we can just leave this and make it a 2. 2 sine of a, and then we can say 2 sine a times sine 35 degrees. So 2 sine a times sine 35 degrees times sine 35 degrees. Right, all of that is going to be equal to sine of 65 minus alpha, right? Sine 65 minus alpha. Now let's expand sine 65 minus alpha, and then we'll probably divide by cosine of a to obtain the tangent, right? So now sine of 65 minus alpha by the formula is going to be sine 65 degrees times cosine alpha minus sine of alpha cosine 65 degrees. Okay, so now let's divide both sides of the equation by cosine of alpha, right? Because then we'll get tangent, because sine over cosine equals tangent. So let's divide both sides here by cosine of alpha. So let me just get rid of this middle part and then move this part up. So right, 2 sine a sine 35 degrees equals sine 65 degrees cosine a minus sine a cosine 65 degrees. If I divide both sides by cosine alpha, right? Okay, so dividing both sides by cosine of alpha is going to give us, okay, so this becomes tan of alpha right here, right? So, whoops. So sine alpha over cosine alpha gives me tan alpha, so get rid of that. 2 tan alpha sine 35 degrees. Cosines here are going to cancel, so this just becomes sine 65 degrees minus tan alpha cosine 65 degrees. Minus tan alpha cosine 65 degrees, right? Okay, so now let's move the tan alphas over in factor. So then we'll get tan of alpha times 2 sine 35 degrees minus cosine 65 degrees, or plus cosine 65 degrees, sorry. That's going to be equal to sine 65 degrees. So our tan of alpha is going to be sine 65 degrees over 2 sine 35 degrees plus cosine 65 degrees. So let me write that. So this means that tan of alpha is going to be equal to sine 65 degrees over 2 sine 35 degrees plus cosine 65 degrees. Okay, so we know that cosine of 65 degrees, right? That's going to be the same thing as sine of 25 degrees. So sine 65 degrees over 2 sine 35 degrees plus sine of 25 degrees, right? Plus sine 25 degrees. Okay, so now what we want to do is we want to write sine of 35 degrees and sine of 25 degrees in terms of sine of 30 and sine of 5. So, for example, sine of 35 degrees is going to be equal to sine of 30 degrees plus 5, right? So we know the value of sine 30 is 1/2. So that's going to be 1/2 sine of 5, or sine of 5 degrees over 2. Or, sorry, it's sine of 30 cosine of 5 degrees. So cosine of 5 degrees over 1/2. Cosine of 5 degrees over 2. And then we're going to add cosine of 30 degrees, which is root 3 over 2, times sine of 5. Right, and then similarly, if we do the same thing for sine of 25 degrees, right, we'll get sine of 25 degrees is equal to sine of 30 minus 5. So it's just this expression, but with the minus sign instead of the plus sign, right? So, okay. Now we have, so this is going to be sine of 35 degrees equals this, and then sine of 25 degrees equals cosine of 5 over 2 minus root 3 over 2 sine 5. Try to fit that. Okay. So now sine of 35 degrees is being multiplied by 2. So the denominator here is going to become cosine of 5 plus root 3 sine of 5 plus cosine of 5 over 2 minus root 3 over 2 sine of 5. So overall, that's going to simplify to 3 cosine of 5 degrees plus root 3 sine of 5 degrees all over 2. So all of this is going to simplify, right? So we can set this equal to sine of 65 degrees over, and then we'll have 3 cosine 5 degrees. And then we'll have root 3 sine 5 degrees. And then we can move the 2 on top for now. Okay, now we can distribute this. So actually, no, never mind. Let's keep the 2 down here. So now we can factor out a root 3. Right, sine 65 degrees. Then we can say this is equal to root 3 times root 3 over 2 cosine 5. Cosine 5 degrees plus sine 5 degrees over 2. Now, if you notice here, right, root 3 over 2 is just cosine of 30 degrees. And 1/2 is sine of 30 degrees. So we can replace the radicals here with just the trig functions, right? So root 3 over 2 becomes cosine 30. So root 3 cosine 30 degrees times sine 5 degrees, or times cosine 5 degrees, plus sine 30 sine 5. Sine of 5. Oops. So now this looks like cosine 25 degrees, right? It's just the expansion of cosine 25 degrees. So this becomes root 3 cosine 25 degrees. Now cosine of 25 degrees is the same thing as sine 65 degrees. So the sine 65 degrees cancel, and we're left with 1 over root 3. Okay, so now back to our angle alpha, right? We can take the inverse of tangent on both sides, right? So we have tan of alpha equals 1 over root 3. So that means alpha is equal to the arctan of 1 over root 3. Right, so 1 over root 3, that looks similar to our 30, 60, 90 right triangle. So we'll have x root 3, so, and then 2. So this is obviously going to be 30 degrees, right? Because tan is going to be opposite over adjacent, so 30 degrees is going to be up here, right? So that means that alpha is going to be equal to 30 degrees. And now the problem is asking for the measure of BAD. So we add that to our original 55 degrees to obtain 55 plus 30 equals 85 degrees, which is our final answer for this problem.